What is up guys, this is Luke Hill for Kikuru, and now we all know that 13-inch class ultra-portable laptops can be ideal for those who need horsepower on the go, excellent battery life, but also the ability to sling the devices in a handbag or, for example, a laptop pouch or a rucksack to go into work or school. Historically, the 13-inch class of laptop has been an area where Intel and its low-power U series chips has really asserted dominance over the years. However, AMD did fight that position fiercely with Zen 2 Ryzen 4000U that we saw last year, and now Team Red is aiming to take the fight even further with Zen 3 based Ryzen 5000U. In this video, we have a couple of very comparable ASUS ZenBook 13-inch ultra-portable laptops, and we will be using them to compare Intel's Core i7 1165 G7 against its new direct competitor, AMD's brand new Ryzen 7 5800U. With both chips run at a relatively low power state of around 15 watt TDP mode in these devices, not the typical 25 watts plus gas guzzling mode that we see in gaming type devices of a similar form factor. It should be interesting to see how both of these processors, one from Intel, one from AMD, compare in a low power environment. So let's test them head to head. Before we take a closer look at the hardware though, make sure you give us a like and subscribe and hit the bell icon on the YouTube channel. That really does help us grow the channel and helps us bring you more content. And make sure you check out the written review on the Kikuru website. That's a really good source of information. Let's start off with the Ryzen 7 5800U equipped ASUS ZenBook 13 OLED UM325. Bit of a mouthful on the name there. This 8-core, 16-thread Cezanne-based APU chip is built around the Zen 3 compute cores. That means you get 16 megabytes of L3 cache and 4 megabytes of L2 cache squeezed into the 15 watt nominal TDP. There is, however, a configurable TDP mode of between 10 and 25 watts at the manufacturer's discretion according to AMD. Built around TSMC 7nm FinFET technology, the single CCX 8-core chip has a maximum boost clock of about 4.4 GHz according to AMD and a 1.9 GHz base clock. That's an increase of 100 MHz on the base clock and about 200 MHz on the maximum boost clock versus the Ryzen 7 4800U that the 5800U replaces. Somewhat disappointingly, we still get the same old, if you like, Vega GPU architecture for the 5800U's GPU side of things. You do get a 250 MHz maximum frequency bump according to AMD versus the 4800U. However, it's unlikely we're going to see the 5800U in a power confined mode really operating at 2 GHz consistently on the graphics cores. A little change is seen for Ryzen 5000U in terms of memory support, PCIe Gen 3, not Gen 4 lanes, and also multimedia capability. This is somewhat intentional by AMD to allow laptop vendors to quickly upgrade their Ryzen 4000 designs for Ryzen 5000 chips. However, AMD does highlight some improvements for the Ryzen Cezanne chips in terms of voltages and power management, which should help battery life. For more details on the Ryzen 5000 mobile CPU architecture, see our launch review of the Ryzen 9 5980HS inside the ASUS ROG Flow X13 laptop. The information there is relevant as the 7nm 180mm squared 10.7 billion FET Ryzen 5000 mobile SoCs are primarily differentiated by their TDPs and therefore clock speeds up the stack. One key point to note is that not all Ryzen 5000 APUs are actually Zen 3. Some of the slightly lower end models are actually Zen 2 based Lucien cores. That's an important difference and can usually be identified by the amount of cache on the chip that you're looking at buying. So Zen 3 on a core for core basis will have higher cache capacity than a core for core comparison to the Zen 2 Lucien chips. Watch out for that one because it's a bit disappointing by AMD's naming team. If we take a brief overview of the laptop itself, the ASUS ZenBook 13 OLED UM325S looks to be geared towards prosumers, heavy users, and perhaps even content creators who need an ultra-portable laptop with processing grunt. The main components are a Ryzen 7 5800U APU in the 15 watt TDP nominal mode, 16 gigs of LPDDR4X 3733 MHz memory, you get a 1TB SK Hynix NVMe SSD, and you've got a 67 watt-hour battery. The The screen is a 13.3-inch Full HD 16:9 OLED display, which is non-touch, but it does have 100% DCI P3 color gamut. Now switching to the Core i7 1165 G7 equipped ASUS ZenBook Flip S UX371. Tiger Lake is a known entity at this point, but we will briefly recap the core specifications of the Core i7. The 1165 G7 features 4 cores and 8 threads, and that's built on Intel's 10nm super thin process node. You get 12 megs of Intel Smart Cache, and ASUS actually runs the chip in the 12-watt TDP down mode, which according to Intel gives it a lowly 1.2 GHz nominal clock speed. Intel is particularly strong this generation in terms of on-chip graphics. The Iris Xe iGPU features 96 execution units and clocks up to 1.3 GHz maximum, and quick sync video acceleration is always a good inclusion in our minds, especially with Tiger Lake's multimedia capability proficiencies. Interestingly, it's easy to argue that Intel actually beats AMD in terms of pure connectivity. Tiger Lake supports both Thunderbolt 4 and PCIe Gen 4. Thunderbolt 4 in particular enables access to a superb, well-defined ecosystem of external devices as high-end as eGPU boxes, for example. If we now take a brief look at the unit itself, the ASUS ZenBook Flip S UX371 looks to be geared towards prosumers who value portability and the 2-in-1 touchscreen laptop design. The main components are a Core i7 1165 G7 in the 12-watt TDP down mode by default. You get 16 gigs of LPDDR4X 4266 MHz memory. 1TB WD-SN730 NVMe drive serves storage. The battery is a 67 Wh unit. And the screen is a 13.3-inch 4K OLED touch display. Moving on to the test procedures, we test laptops in the out-of-the-box state with obviously our software deployed and also Windows updates applied. The first thing we did with these ASUS laptops was not make any key adjustments to the included software other than McAfee. We had to remove that trash because it was just frustrating. ASUS, please stop including this. It pops up and annoys everybody, I'm sure. That means that each laptop is running its standard fan and power mode. For the Ryzen 7 chip, that's around about 15 watts long duration TDP, and we tested the Intel chip to be running about 12 watts long duration TDP. We also throw in a bit of testing for the performance, fan and power mode, and for the Ryzen chip that was around about 18 to 21 watts long duration TDP in our testing, and the Intel chip was around 15 watts long duration TDP in this performance mode. We include comparison data from some relevant laptops that we have tested recently. One important note is that we've included test data from a Lenovo Yoga Slim 7 laptop that uses a Ryzen 7 4800U processor that this Ryzen 7 5800U in the ASUS ZenBook actually replaces. That Lenovo laptop, however, runs the older Ryzen 7 chip at considerably higher power allocation of around 25 watts plus for long duration test runs. As such, the older Zen 2 Ryzen 7 in the Lenovo unit will often appear faster in heavily multi-threaded tests than the new Zen 3 Ryzen 7 in this slim and light ASUS ZenBook. But this performance difference is realistically down to the choices of the laptop makers themselves and not really the APU versus APU comparison when looking at the AMD chips. This is an important observation to bear in mind, and we will leave the Ryzen 7 4800U data in the chart, but do watch out because it is run at a different power mode. As always, if you want more information on our test procedures, the laptops themselves, and everything else, just head on over to the written review on the Kickguru website. Let's look at the performance. Heavy multi-threaded CPU performance from the Ryzen 7 5800U is impressive, and that is particularly true for the Cinebench R23 and Blender long runs, whereby Intel's lofty short-duration power states hold less influence. Seeing AMD's 8-core 15-watt chip batting against a 45-watt gaming caliber option from Intel is eye-opening, quite frankly. The i7 1165 G7 is comprehensively beaten by the AMD low-power silicon. Handbrake video conversion sees AMD delivering a massive stomping versus the 1165 G7 in comparable power modes. In fact, the AMD U series chip is over twice as fast for our H.265 and H.264 workloads. 7-zip's more lightly threaded workload flies on Zen 3 cores and high-speed LPDDR4X memory, especially in terms of decompression. This is the first test to show off the Zen 3 benefits versus Zen 2, even with our Ryzen 7 4800U test sample running at higher power. Focusing now on 1T performance in Cinebench, AMD has closed the gap to Intel Tiger Lake here. In fact, the reduced power states allow the Ryzen 7 5800U to actually outperform the Core i7 1165 G7, and the 5800U's improvement over the Zen 2 4800U with a higher power budget is significant. In terms of CPU-based clock speed consistency, not even 10 minutes of heavy load and heat soak can reduce the AMD chip's clock speed and corresponding performance to anywhere near as low as Intel levels. As a side note, we also saw the Ryzen 7 5800U outperforming the Core i7 1165 G7 by a little over 50% in Cinebench R20 NT for an on-battery test run. Memory latency and overall bandwidth is an area where the Ryzen 7 5800U in our test sample struggles versus Intel Tiger Lake. This is important, as memory bandwidth is a core component in the equation for iGPU performance proficiency. FutureMark's 3D Mark Gaming and PC Mark 10 general usage tests show AMD's Ryzen 7 5800U once again beating the Core i7 1165 G7. The CPU-based performance improvements for AMD look to be holding true even in gaming type and varied workloads. But now we can have a closer look at some actual gaming tests with direct side-by-side comparisons for these laptops. We're doing a little bit of gaming here. We've got Rocket League loaded up and we're actually running at 1600 by 900 resolution, full screen. AA is off, but we've got high quality generally across the board. So I'm just going to sit here in the casual mode and let the game tick over, just so we can see how the performance compares side by side. What we actually see is the Intel system looks to be faster here. It's pretty consistent around about high 60s or 70s, whereas the AMD system, also running DirectX 11, looks to be topping out at just over a gigahertz, so around about a gigahertz on the GPU frequency, full load there, but it's actually running at about kind of mid 50 FPS range. And if I move about, we'll see that this is probably going to stay quite consistent. Right now, looks like Intel's a bit quicker. We're now in Grand Theft Auto 5. This has been running for a few minutes, so the systems are, again, nice and hot. You can certainly feel that, and you can see some of the temperature readings. We're running again at 1600 by 900 on both systems, and we've got the same settings across the board. Generally the lowest settings available, so this is a mix of off for AA and anisotropic filtering, and also we've got kind of normal for the image quality mode. Here in this fly-in part for Grand Theft Auto, we can see that the AMD system starts out at around about kind of 60 FPS and is now hovering around about the mid to high 50s. Coming up to the 60s and over the 70s. So the same position on the Intel system is kind of starting off about mid 30s, then coming up to about the 40s and the 50s. Of course, the AMD system was a bit quicker to get into the game and is progressed through the benchmark a little bit quicker, so it's a little bit ahead. But you can see there is quite a big frame difference. Over the highway, we're about 80 FPS on average, and the Intel system's just about to come into the highway stretch, and we're looking at kind of high 40s, maybe 50s, jump up to a 60. So we are considerably faster on the AMD system at this point. The Intel system's looking at about kind of the 40s or 50s range, so not ideal, a little bit choppy, whereas on the AMD APU, the Ryzen 7 5800U, that's perfectly fine actually, even when we're dropping down to the 50s. It's not too bad at all. Now we're running some F1 2020. Again, we're 1600 by 9 for the resolution. We've just cranked down a lot of the settings. We've left the 16x AF on both systems. If I just go over to the advanced setup so we can see what our presets are, we are on the ultra low preset just because we didn't want to really push these systems too hard. We want to give them an actual chance of being able to do some stuff. So let's run the benchmark and then we'll have a look what the numbers are. Well, I guess this is a good point to highlight. What we're seeing already is that the AMD system is just considerably faster in terms of gaming. The Intel system, actually this may have frozen. We clicked run benchmark test at the same time. The AMD system's already chomping through the benchmark at reasonable frame rates actually. And well, I think the Intel system is, I think it could have been locked up. Yeah, the Intel system is basically unusable. Let's try again. At the moment, this looks quite competitive versus AMD. We can see the CPU is running it at its basically 12 watt power mode. However, AMD is faster, and in the ZenBook AMD version, we do have more headroom to push the power higher on the 5800U. Now that we've finished up the benchmark, we can see that the Intel system actually does a decent job eventually, coming in at about 45 average FPS. The minimum, however, is 27 according to the built-in benchmark, so AMD is considerably better here. Only about 3 FPS higher on the average at 48 FPS, but the minimum FPS is 43 FPS, and the consistency was far, far superior. A win for the 5800U here, convincingly, especially given the freezes that we saw initially in the benchmark. We've got both systems running the Shadow of the Tomb Raider benchmark here, 1600 by 900 on the lowest image quality settings. The AMD system's a little bit behind, and that's because the Intel version takes quite a while to load the different modes in the benchmark. As we can see, massive pop in there with regards to the actual display, so yeah, not a great solution for the Core i7 1165 G7. We'll have to see what the 5800U is doing in this region in terms of frame rates. The 5800U starting off the valley at around about kind of low 50 FPS region. It's not bad at all, quite a bit higher than what we're seeing from Intel. And then we see the 1165 G7 doing a kind of about low to mid 20s when we're going through the town with the people. And we'll just bear that in mind for when the AMD system catches up and gets to the point with the town and the people. And we can see when AMD comes through the town and the people are there, it's kind of low 30, so about 31, 32 FPS. So about 8 or so FPS higher than what we saw from the Intel system. So the Ryzen 7 5800U finished with around 34 FPS on average versus the 28 FPS average for the Core i7 1165 G7. As we saw though from the benchmark and from the video playback, that doesn't really tell the whole story because the AMD chip was far more stable and consistent with its frame rates, and we didn't really have the slow loading times or the texture pop-ins that we saw on the Core i7 system. So at this power mode in Shadow of the Tomb Raider, AMD wins convincingly. Media consumption is an area where Intel clearly dominates, especially for high-resolution online media. So if we run some 8K 60 video via YouTube and then hide the video to avoid a copyright strike, we can see basically no drop frames or next to no drop frames on the Intel system, and it's a juddery, stuttering mess on the AMD system. It basically just doesn't play. What we see is that the GPU on the AMD system is just basically tapped out fully for video codec playback, so video decode, even though it's not technically using the decode engine according to Windows. And Intel's chomping along smoothly, and it's actually got its secondary decode unit doing literally nothing, so you can load up another stream simultaneously. We've now loaded up one of the Kikuru reviews, so this is 4K 60 via YouTube. This is fine on the AMD Ryzen 7 5800U system, and we can see the video codec at about 64 to 70%. So realistically, one stream of 4K 60 VP9 over YouTube is fine. Anything more and you're going to start to struggle. The Intel system breezes through this 8K 60 plus 4K 60 at the same time, and if we want, we can even open up some VLC media and play VLC media player at the same time, and you're just not going to have to worry about system decode. So this really is an absolutely dominant performance for media consumption from the Tiger Lake chip. ASUS deploys a better WD-SN730 SSD on the Intel system, but the AMD laptop's SK Hynix 1TB drive does, however, hit 3GB per second writes. Thankfully, neither drive had cooling issues with the heavy sustained workloads. A battery life comparison is slightly unfair versus the 4K OLED touchscreen for the ZenBook Intel version. What we can say though is that AMD's efforts with battery life on Ryzen 4000U and the new Ryzen 5000U have delivered some phenomenal results. Temperature-wise, you shouldn't really have any major cooling concerns with the Ryzen 7 5800U. Unlike its Intel competitor, the AMD chip tends to stick below 80 degrees Celsius in heavy sustained workloads, and it's stabilised around low to mid 60s in our testing. The 1165 G7 in the ZenBook Flip S stabilised around 70 degrees Celsius after initially hitting 90 degrees Celsius under its turbo boost mode. Let's take a closer look at noise output now. We've been running Cinebench R23 multi-core load for just under 15 minutes on the Core i7 1165 G7. The temperature on the CPU is around about 70s and the frequency is just under 2 GHz, maybe up to 2.1 GHz, depending on which section it is. So let's just have a look at the noise output from the ASUS ZenBook. About 40 to 41 decibels and perfectly tolerable. Definitely audible, but very tolerable. Just under 15 minutes worth of runtime on the Ryzen 7 5800U system with Cinebench R23. The CPU is around about 1.9 GHz on all cores, and the package power is about 12.5 watts, so it's actually currently slightly below the 15 watts that we were typically seeing for long duration using our Cinebench R20 testing. The temperature is around about 64 degrees Celsius according to HW Info, so we'll have a look at the noise level now. About 43 decibels on our noise meter, so about 2 decibels or so louder than the Intel system, but we do have to remember that actually this system is now dissipating a little bit more power and is offering considerably higher performance. Either way, the fan speed is not bad. It is a tad louder than the Intel-based ZenBook, but it's very tolerable. If we now make a comparison directly, both laptops feature a sleek, lightweight design that is comparable in many ways. Their form factor is almost identical at about 30 centimeters wide and 20 centimeters deep and sub 1.4 centimeters thick. Weight is also comparable at around less than 1.2 kilos. The backlit keyboard and trackpad design is equally high quality and sturdy on both, and the Windows Hello IR camera is functional but not mind-blowing in terms of quality on either of the laptops. This AMD version camera that I'm looking into now is very comparable to the unit on the Intel version. I do slightly prefer the Intel version that I'm looking into now, but I think that's because the colours on the screen are a little bit better. There's no denying that the 4K OLED touchscreen on the Intel model is just better to look at and use, and that's especially true with the glossy panel, full rotation capability, and lesser use of plastic in the bezel. Connectivity is also a win for the Intel device. There will be users who value the microSD card slot on the AMD version of the laptop. However, Intel clearly bests AMD's approach with dual Thunderbolt 4 ports. Comparing performance though, this is where AMD wins convincingly. Even in a very comparable low power allocation mode, the Ryzen 7 5800U comprehensively destroys the Core i7-1165 G7 in any form of demanding CPU workload. AMD's GPU side performance is also strong for raw processing and frame power. However, Intel arguably has better media consumption capability, with even 8K 60 from YouTube being a breeze for the Core i7's iGPU. And in terms of pricing, the ZenBook Flip S UX371 in our tested configuration is somewhere around £1,500 in the UK. Our ASUS contact highlights that the ZenBook 13 OLED UM325 with Ryzen chip is not currently available in the UK, and they did suggest that it won't be coming to the UK. However, there is a web page on Amazon selling this, though it's currently unavailable. So, not entirely sure there. We have, however, seen that the Intel version is around about £1,100 in the UK, so we expect the AMD version with a bigger SSD to be a little bit more expensive, especially factoring in this OLED screen. Don't put too much weight on pricing though, as these technically aren't direct competitors, especially with the 4K 2-in-1 design of the Intel version. We just wanted to be able to compare the chips on a like-for-like basis in their low power states for these ultra-portable 13-inch laptops. Overall then, Ryzen 7 5800U looks to be an excellent choice for ultra-portable laptops, especially in this low power mode. You get superb performance at constricted power levels, solid battery life, and decent platform capabilities. AMD does need to address a glaring lack of Thunderbolt support though, and we'd also like to see improvements made to the multimedia engine of the iGPU going forward. And now focusing on ASUS, they really do deserve credit for deploying AMD's new chip in a device that offers many of the same fundamental features as the Intel competitor. That is quite a change in market conditions and spells a high vote of confidence in the AMD processor. Just a few generations ago, the AMD chips would have been reserved for lower cost second-tier devices. Now though, ASUS deploys the Ryzen 7 5800U in a premium design with minimal corner cutting compared to the Intel version, and that really does make the ZenBook 13 OLED a very appealing and alluring laptop based around the AMD silicon. Thank you for watching this video review and head-to-head comparison between Intel's Core i7-1165 G7 and the new Ryzen 7 5800U, which is the primary focus of this review. Let us know what you think in the comment section down below. Are you pretty impressed with what ASUS has squeezed into these sleek 13-inch ultra-portable form factors? How fast did you expect the Ryzen 7 to be? Are you impressed by the performance? Or would you like to see more with a higher power TDP state? Let us know in the comment section down below. If you like this video, give us a like and subscribe, do all that usual YouTube stuff, bell icon, etc. Support us by checking out the Kicker written channel. That really helps us out and helps us grow the YouTube channel also. And you can buy a cool t-shirt like this one. You can interact with us on Discord and other social media, and I'll catch you in the next one.